Okay, this is a project where I'm going to take two Arduino Unos with the Ethernet shields and have them talk to each other, have them talk between the two units using UDP Communications. And this is a diagram of what it's going to do. So I have what's called board number 1 and then board number 2 over here. So this is Arduino Uno board 1 and Arduino Uno board number 2. And I have an Ethernet switch over here. So I'm going to have communications. I'm going to write data through the switch to the other board and vice versa. So they're going to be sending data back and forth to each other. So I also have two PCs. This is a block diagram of my setup. So I call PC number 1 feeds board number 1, and this is to develop the software. This has a software hosted on it that I download to the Arduino Uno, and PC number 2 also has the software. Now both programs are very similar. There's only differences when I'm going to send the data back and forth to identify the IP addresses, but the programs are identical. Now I also have what's called a throwing star in there, so I can monitor some of the data using Wireshark. So I want to take a look at some of the data that's flowing through this just for analysis purposes and instrumentation purposes. Now this system will run by itself without the PC, so when I take the PCs away, break the USB cables, the two systems will still talk to each other. Well, I can't do it without power though. The USB provides power to these boards. If I had a power supply for them, then they would talk to each other independently without the PC. So these two boards will run the same. They'll run without the PC itself. So what I have over here now are the components that I need for this project. So I have an Arduino Uno with an Ethernet shield, while the Uno's on the bottom here, the Ethernet shield's on top. It's kind of like sandwiched on there, and it has a USB connection there. So this is going to be called board 1, and this is board 2, which is identical to board 1. They're both the same devices. So the purpose is just to send data back and forth using UDP Ethernet Communications. So what I also have here is I have a router. It's a wireless router, but I'm not going to use it in that way. I'm just going to use it as a switch. So I'm not going to use the wide area network. I'm just going to use this as a switch to connect the two units together. So what I do is I'm going to connect board 1 to port 1 and board 2 to port 2. I'm not going to use the wide area network, so this blue port isn't going to be connected. Only the orange ones would be connected. So this is an Ethernet switch, and it's set up pretty much the default conditions where the IP address is 192.168.0.1, and there's a subnet mask. It's set to 255.255.255.0, and I think the subnet mask will limit me. I could set these up to any IP address that I want to, but they all have to be on the same subnet mask. So I can only so the first 3 digits are the same, but the last one could be different. So that's one constraint that I have, but I can really set these to any IP address. Now the other thing I have here is the throwing star, and I showed that how I'm going to hook that up. This is just so I can use Wireshark in an easier way. So I'll pass one of the Ethernets through the black connectors here, and the yellow one will go to a PC so I can monitor some of the data using Wireshark. So this comes in handy. What it is it breaks it only allows the transmit, so the PC will receive the data, but it can't transmit on the bus. So this prevents the PC from trying to connect to the bus and trying to, that throws off the data. So this gives you a convenient way of just looking at the data. Now UDP is kind of open loop, it's connectionless, so it just spits out the data. The other thing I need are some Ethernet RJ45 connectors here, so cables, so I have those over there. So that's pretty much the components I need. Now in your setup, the main thing is just having the two Arduino Unos with the Ethernet shield so they can communicate with each other. You may not need all this stuff. I also had used hubs, and hubs will work, and also any of the big Ethernet switches will work, but I had tried some of the smaller Ethernet switches and those won't work with this. So what works good is just the wireless router, and but not using the wireless part of it, just using it as a switch seemed to work good with this. So these are the two monitors that I'm going to use, the two computers I have on the left side here. I have a Windows 7 computer, and on the right side I have a Windows 10 computer. So I'm going to call the Windows 7 on the left system number 1 or board number 1, and the one on the right is going to be called board number 2. And I'm going to show you how to hook this up. So these are the two monitors and the two keyboards I'm going to use to show that the communications is going on between these two Arduino Unos and Ethernet shields. So up here I have the computers that I'm going to use, and I'm going to show you how I hook that up. So I'm going to hook that up now and show you how that works. So the first thing I'm going to do is get my Arduino Uno board number 1. And that's this over here, and I'm going to connect that into the computer. So I'm going to connect it into this USB port here for this computer I call PC number 1. And I'm going to try to find a way to clamp this up here. So I'll stay up here so you can see it. So I have a little clamp here, and I'm just going to clamp this up here and try to turn this so you can see some of the lights on here. Okay. So now I'm going to get the second unit, and I'm going to connect that also. And I'm going to connect the USB port into here, into this other computer. If I can get it in there. There it goes. And I'm going to clamp this up here so you can see the lights flashing. Now the lights give you a lot of information on whether it made link and it's transmitting. You can read more about the Ethernet shields. There's a lot of good documentation on that around. So I have those hanging. So now I'm going to connect the Ethernet, the RJ45s. I'm going to connect up the RJ45s. So to this one, I'm going to connect the RJ45 to this one, just like that. So that's the green one. And now I have a blue RJ45 cable I'm going to connect to the second one. So I'm trying to orient these in a way so number 1 is on the left and number 2 is on the right, just to make it easier to keep track of. Oh, I lost my clamp, but I have another one here, a backup, that I'm going to try to connect this back up here. So there it goes. It's not quite straight, but good enough for what I need to do here. So now I'm going to show you how to connect the Ethernet switch. So the first thing I want to do is power it up. I want to put some power on there. So I'm going to plug that in. So now I get the blue cable here. I'm going to turn on the switch. So the blue cable, I'm going to put that into port 2 over here. So I'm going to put that into port 2. Now the other cable, I want to use the throwing star. So I have the throwing star here. So I'm going to hook J1 of the throwing star to port 1 of the switch. So that goes over here, and then this is going to the Arduino board 1, the green one, so I'm going to hook that to J2. So now I have a black RJ45 cable, and I'm going to hook that to my PC so I can monitor the data using Wireshark. So this is the throwing star. So I'm just showing you how I connected this up. So over here I have, this is board 1 coming in, and this is board 2. You can actually see the switch is flashing now, indicating that there is data coming through, because I already had the program loaded from before. So you can see the data indications over there on the switch. So over here you can see the two Arduino Uno shields. and the lights are really blinking. They're transmitting and receiving. They're going crazy here. So there's data transmitting back and forth between the two boards, and so you can see the lights flashing over there, and there's data transmitting back and forth between the two boards. And down here I have my two computers, and I have our Arduino software ready to go with the program. So I'm going to go through the code here with you, and I'll show you how to program this. It's a pretty simple program, so I'm going to go through that. I'll go through one of them. They're almost identical. The two of them are identical. So let's see, maybe you could pick this one over here, and we'll go through that one. Okay, I'm going to go through some of the code here with you, and the first line in here is an include here. So I have an include spi.h. Now this is the library for the serial, that's the SPI interface that the Ethernet shield uses, so you have to have that in your first line. The second line is include for the Ethernet library, so it says include ethernet.h. The second line, the third line now, is for the UDP part of the Ethernet library. So that has to include Ethernet UDP.h. So the next line here is line 5. I'm just defining an array size of 32 that I'm going to use. I'm going to have a write and a read vector that has an array of 32 to send the data back and forth. I had to experiment, and the most I can make this is about 700 with the Uno. I'd have to go to a bigger processor, a bigger Arduino, a larger, higher performance one that had more memory if I want to go beyond 700. But I did test it up to 700, and I was getting some pretty good throughput on this. So the next line here, line 7, defines, I call it data 1. It's a byte array that's the 32 bytes long, and this is my write vector. So this is the data. I'm going to fill this up and send it out. I'm going to write to the other device, to write to the other Arduino Uno shield. And this is my read vector data too. So this is also a 32 byte vector that I'm going to read the data back, coming back from the other device, from the remote device. So I have a local device, and I call the other one the foreign device. So the two programs on the two Arduinos are almost the same. It's just the IP addresses are set up different, and the port is set up different. Okay, so the next line is I set up a MAC, and this is the MAC for board number 1. So I just set everything to 1s, all 1s. On the other program, I set it all to 2s. So just to identify the board, you could kind of pick a number. They have to be different though. You can't have the same MAC. You'll have a conflict with the switch, so you want to make sure they're different. So the next thing is the IP address. So I set the IP address to all 1s, 111.111.111.111. So this is my local device, and I set my port also to all 1s. So it's 5 1s here. It's 11111, and this is the port. So it's for the different levels, the different layers of Ethernet. So I know the MAC is at I believe it's the link level, and then the IP is the network level, and the port is at the transport level. So this is the different levels that we're using and the different layers. So now I go to, so that sets up my local device. So now I need to identify my foreign device that I'm going to send the data to. So I picked, you could pick whatever IPs you want in this. You have a lot of flexibility, but I picked, for the remote device, I picked 111.111.111.222. See, I couldn't put all 2s in here because I believe the subnet mask, the way that's set on the switch, I believe it's set to 255.255.255.0. So I'm only allowed to change the last 3 digits here. I can't change the other ones. Otherwise, I could change the subnet mask and make it a bigger network, but I can't get more than 255 on here. So I can't get more than 256 devices on this network. If I wanted more, I would have to change the subnet mask. So I made the remote port for the transport layer on the foreign board 222222. Okay, I'm just doing this to help identify the boards and make it a little bit easier to understand how this works. Okay, well the next line here is you have to define with the library, you have to define a UDP instance. This is the type, Ethernet UDP, a UDP type. So that's what you have to do to make the library work for the Arduino Uno. These are the standard libraries that you can get from the Arduino website. There are other ones around that do other things, but this is, I'm trying to keep to the standard one that you can you already get when you download the Arduino software. Okay, the next part here is the setup. Okay, so the setup part is pretty simple. The first thing I wanted to do here is just set up a serial interface. So I want my serial interfaces to be fairly fast. This is just for monitoring purposes. When you go to a production system and you don't need the monitor on a PC, you could get rid of the serial interface. You won't need that anymore, and you could take advantage of some higher performance. So I set the baud rate to 115,200, and I set this up so it doesn't start up until I look at it serially. You can get rid of this when you go to like a non-debug version. So the next section here in the setup is I just set the write buffer as an array from I set it from 0 to 31. This way fills the array with different data. Now I'm going to take the first element of that array and increment it to prove that the data is getting over to the other side. So, but for now I set all the other bits of data, the bytes. This is the data that I'm writing over. So I set this array from 0 to 31, and it's a 32 element array. So the next thing you have to do is start the Ethernet, and so this is the UDP library. So this is a library thing where the MAC is, I define that, and you define the IP above, and it's going to begin the Ethernet library. And this tells UDP what the local port is. So the next thing I do is I just print out the local IP address, and I just do this for debugging purposes, so I know which board's which and which computer's which. So this is the end of the setup phase. So now I'm going to go to the loop part. So this is the setup phase, just happens once, and a loop part happens over and over again. Okay, so the first section, actually these first three lines of code, is the write. So I'm going to write that array over. So the first thing you have to do is do a UDP begin packet, and you put the remote IP and the remote port in, and then you do the write, the UDP write. So this is the data, which is 32 bytes, which could be larger or smaller depending on your application. The most I could get using the Arduino Uno is 700. Possibly if I didn't use an array, I could not use as much memory, I could probably get more than 700. The packets for Ethernet are about 1400 bytes, are probably the biggest you can send over. So this is a relatively small one. This is the final command for the write part. These three lines is the write part. So when you do the UDP end packet, it actually does the write. And then I waited 100 milliseconds. So I wrote and wait 100 milliseconds, and then this part down here is the read part. So we're going to go through the read part now, and I'm going to try to scroll up here so you can see it. So this is the read part now. Okay, so the first part you have to do is you're looking for data coming back. So there's a command in the library called UDP parse packet. So if it senses something greater than 0, it's going to read it. If it's less than 0, if it's 0, it's not going to read anything. So I'm going to show you how that's done. Just wanted to make sure I could scroll up here so you could see it, because it's getting towards the end here. What I'm going to do is add just a bunch of blank lines here so you could see this, okay? Because I know my screen is cut off on the video. Okay, so the command here is if the packet size is greater than 0, that means I received something. It's going to print out, received the packet size, and it's going to print out the size of the packet. In this case, it's 32 bytes, so you'll see a 32 come up here, and it's going to tell you where it came from. So it's coming from IP address. It's going to come from the remote IP address, which in this case was, I set it to 111.111.111.222. So that's going to be the remote IP address. So this over here, what it does is that it this over here, what it does is it just prints out the remote IP address. So it's the four elements. It's actually like an octal type of number in decimal form, so it can't be more than 255. So this prints out the IP address. You won't need this if you do a production version where you don't need to debug anything. So the next thing it does is it prints out the port number. So the remote port was set to 22222 while the local one was set to 1111. So here's the point where it actually reads the packet. So that's up over here. So it's going to read this packet and put it into the array called data 2, and it's also 32 bytes. So that's the point where it reads it, and then what I have over here is I'm just going to print it out on the serial monitor so I could see the data. So it's going to set this, it's going to set 0 to 31. It's going to give me the 32 byte. It skips a space here between each byte here, and then I put this in here so it goes to the next line so it doesn't get too cluttered. And over here, this is where I increment my first element of the write array data, which is 0. So I do an increment, so the next time it goes around, it's going to write and it's going to increment 1. So that's how when I see that incrementing on the other Arduino Uno, then I know I'm getting fresh data. I'm not getting stale data. So I'm getting data, and I can verify that I'm getting the data. So that's pretty much the code of this, and that's all it is. So now I'm going to compile and upload the software for the 2 units. So I go to board 1, compile it and upload it, and go to board 2, compile it and upload it. So it's compiling now. Number 1's done uploading, and number 2 is uploading, and number 2 is uploading. So now I'm going to run the serial monitors here. So I'm going to go to computer 1 and run that, and computer 2 and run that. So it takes a little bit of time to connect, but now it's connected. So it's up there and running, and so it seems to be running, and there it goes. So they're running pretty smoothly. Sometimes it takes a little bit for them to sync up with each other. But I'm going to show you the data here. I'm going to zoom in here a little bit. So this is board 1 over here. So I'm going to show you board 1 over here and zoom in and show you what's happening here. So you could see the incrementer in the first element there, and when it hits 255 it goes back to 0 and restarts again. So this is board number 1. So you could see it's getting data from number 2. So you could see the remote IP address is 111.111.222 and port 22. So that's where it's getting the data from. So now I'm going to go over to the other board, and you can see the same thing, and it's getting data from 111.111, and you can see the first element is incrementing by 1, and it's getting all the 32 bytes of data is coming through. So I'm going to do a little experiment here just to show you what happens if I kill one of the boards. Well, I'm going to kill one of them. So we're looking at number 2 there now, and I'm going to reset number 1. So I'm going to go and hit the reset switch on number 1 just to see what happens. So you see it stops, the data stops, and I let go of the reset switch. Now it starts over again. So it starts over again. So when one side doesn't get data, you could see what happens. So I'm going to zoom back out here again, and we'll go take a look at the boards again. They're up over here hanging where I left them, and you can see the lights, and you can see the data coming through by the lights. So the lights help you see the data come through. Yeah, now I'm going to show you what happens if I disconnect one of the cables. So I'm going to go to the switch and disconnect system number 1. I'm just going to pull the RJ45 out, so I'm going to do that right now. So you see the data stops. So now I'm going to plug it back in, and it starts up again. So the communications is starting up. So board 1 is sending data to board 2, and board 2 sending data to board 1. So now I'm going to use Wireshark and show you how that works. So we have Wireshark hooked up to the PC1. So I'm going to go run Wireshark and try to capture some packets here and show you how that works. So what I'm going to do here is just minimize this, and we're going to run Wireshark. So we're going to run as administrator because the Ethernet doesn't come up on the newer Wireshark. The older versions of Wireshark didn't have that problem, but the newer one, the Ethernet doesn't come up. So you want to click on this local area connection, which I've set up to auto detect. It's just set, it's not set up for any particular IP address. It auto detects the IP address, so it automatically detects IP. So I hit that, and it's going to capture packets. So it's capturing these packets. So I'm interested in these UDP packets. So I'm going to, you get a little bit of other things too, but I'm going to stop this. And we're going to look at some of the packets here. So I don't know if you could see this or not, but this is a packet, this is frame number 90. So the nice thing about Wireshark, you can see the different layers here. Like if you click on this, it gives you the whole frame. But if you click on this, it just gives you the Ethernet part of it. I guess this is called, I believe it's called the link layer. So you could see the source, the MAC addresses here. The source is all 111, 111, and destination's 222 to 222. So you could also see the IP part of it. So this is my IP addresses. So board 1 is all ones, and board 2 is all ones with 2s at the ends. And so this is the network layer, and this is the transport layer. So it's 1111 to 2222. So it's pretty neat. Like I'll highlight in Wireshark, like the different parts of it. So like if you just want to look at the data, it turns blue there. If you want to look at the transport part of it, these codes, you can look up what they all mean. So a lot of it means it's UDP. That's how it knows it's UDP protocol. But the interesting things we want to see is our counter working. So I'm going to look at the data here. So the first element here is 72, and you can see 1, 2, 3, 4, 5. It goes all the way up to 31 there. It's in hexadecimal. So that's frame 90. So I'm expecting that frame, if I captured every bit of data, I'm expecting the next frame 91 to be a 73 here. So I'm going to go up here and hit frame 91. So see, I have the 73 here. So see the 73. So if I go to 92, it should increment more. See the 74. And the next frame should be 75 and so forth. So it goes all the way up to FF and then restarts at 0. So it's pretty neat. You could see, the data is being transmitted from board 1 to board 2. So this is the communications from board 1 to board 2. Now, if I go on the other cable, I'll see everything will be the same, but the source and destination will be swapped. So all the data will be coming back from the other board. So this is an interesting project. It's a wired project. I guess the next step is to try to do some stuff wirelessly, or try some other things like TCP/IP, TCP. This is TCP is much more complicated. That is a connected type of protocol, and you have to do a lot more. UDP is pretty much open loop. It's just constantly transmitting this data, as you can see on Wireshark, over and over again, and you can get it to work with these Arduinos. So you could add. It's a pretty neat way of doing it. You could put a lot more. I only have 2 components, 2 things on a network, but if I wanted to do 3 things or 4 things, I can make a whole network of these and have them all, intercommunicating with each other to send data back and forth. So this is a neat way, a neat project to do if you're interested in Ethernet. Ethernet's very important. It's kind of the backbone of a lot of the internet that we deal with our own computers. So this is a way to get started in that. Anyway, thanks for looking at this.